Once upon a time, in the vibrant little town of Mathlandia, there lived a group of young and curious friends: Alice, Ben, Chloe, and Danny. These friends loved to explore the world around them. One sunny morning, they gathered under the oak tree, and Alice, who was a bright and enthusiastic student, said,
"Hey guys, I just learned about sets in our math class. Sets are like magic boxes that hold different things, and they help us organize stuff. Let me explain to you." Sets. A set is a collection of unique objects or elements grouped together based on a common property, and it does not change from person to person.
Alice brought 2 boxes. One was filled with colourful balls of different sizes, shapes, and materials, and another one was filled with toys.
Wow, that's amazing. But how do we write these sets?
Methods of writing sets.
There are 2 methods. The first one is the listing or roster method, and the other is the set builder or rule method.
She took out a notepad and wrote, "Listing or roster method. B is the set containing basketball, tennis ball, blue toy ball, purple toy ball, pool ball, football."
Wow, that looks great! But what about the set of toys in the toy chest? How can we list all the toys when we don't know what's inside it?
You're absolutely right, Chloe. For sets like the toy chest, where we may not know all the specific elements, we can use the set builder method based on specific properties. We can write the set of toys like this: set builder or rule method.
What does that mean?
The set builder method, we use a property or condition to describe the elements of the set. In this case, X represents any element, and the vertical bar means such that. So, we're saying that T is the set of all elements X, such X is a toy in the toy chest.
That's so cool. So instead of listing all the toys, we use a rule to describe them.
Exactly, Danny. The set builder method helps us write sets when we have a rule or property that defines the elements, even if we didn't know all the elements individually.
The friends realised that the roster method was perfect for sets with specific elements, like the set of different balls they had. On the other hand, the set builder method was ideal for sets that were defined based on specific properties, like the set of toys in the toy chest.
Different types of sets.
Ben, let us take your name. How many alphabets are there between the alphabets B and N in your name? There's only one alphabet, which is a. So the set which contains only one element is called as a singleton set. Danny, tell me, what is a unicorn?
A unicorn is a company that has reached a valuation of $1 billion or more.
So how many unicorns are there in our town?
There is not a single unicorn in our town.
As we don't have any unicorns in our town, the set 2 is empty. This is called an empty or null set. It is denoted as. What if a set has a limited number of elements? For example, the set of days in a week. Sets of this type are called finite sets, and there are infinite sets like the set of whole numbers, which go on forever. Friends, let me show you one interesting thing. Different colors of balls in the box, which is set A that contains orange, optic, yellow, blue, purple, black, white, and different colors of toys in the toy chest, which is set B that contains purple, orange, white, optic, yellow, black, blue. Every element of set A is in set B, and every element of set B is in set A. Then set A and set B are called as equal sets. Though the elements of set A and set B are not in the same order, but all the elements are same. It is symbolically written as an equal sign, B.
Venn diagram.
I can draw a Venn diagram to represent sets. It's like creating a beautiful painting with different shapes. Let's draw one for our set of balls and another for the set of toys.
As they drew the Venn diagrams, they noticed something interesting.
Hey, look! The balls in the overlapping part are present in both sets.
Yes, that's called the intersection of 2 sets. It's like finding common ground between the sets. It is symbolically written as and is read as B intersection T.
Curious to explore more, they started playing with the sets.
What if these set of balls were toys?
Now the set of balls is a part of the set of toys.
Exactly. When one set is entirely contained within another set, it's called a subset. A subset is symbolically written as, and it is read as B as a subset of T.
What if we have a set that contains everything in our town, Mathlandia?
Oh, that's cool. It's called the universal set, which includes everything we're considering. In our case, the universal set is the set of all toys in Mathlandia. Generally, the universal set is denoted by U, and in the Venn diagram, it is represented by a rectangle. Here comes one more term, called the complement of a set. Name the elements which are not in the set of balls. Comment down below. They are called the complement of set of balls. It is denoted by. Similarly, the elements that are not in set T are called the complement of the set of toys.
As they continued to play, they separated both the sets, the set of balls and the set of toys, in two different circles.
Look, the set of toys T have no common elements with the set of balls B. Thus, the pair of sets which does not have any common element are called disjoint sets.
Let's put all the toys together in one big box.
Now they decided to combine the sets B and T and create a new set with all the toys they had.
That's a fantastic idea. The new set we create when we put elements from both sets together is called the union of two sets. It is symbolically written as and is read as B union T.
How many elements are there in a set?
Well, the number of elements in a set is called its cardinality. We simply count the elements to find the cardinality. It is symbolically written as and is read as no of elements in set B. Let's count all the elements of set B, set T, and set U. So the number of elements in set B is 6. Now you tell me the number of elements in set T and U in the comments section below.
Revision of sets.
Let's see what's in the chapter. Number 1, what is a set?
A set is a collection of unique objects or elements grouped together based on a common property, and it does not change from person to person. Example, bunch of keys, whole numbers, etc.
Number 2, methods of writing sets. Listing or roster method and set builder or rule method. Number 3, types of sets.
There are 4 types of sets: singleton set, empty or null set, finite set, and infinite set.
Number 4, equal sets.
The elements of set A and set B are not in the same order, but all the elements are same. A is equal to B.
Number 5, Venn diagram.
A Venn diagram uses different shapes to show similarities and differences between different groups or sets.
Number 6, intersection of two sets.
The intersection of two sets is the collection of elements that are present in both sets simultaneously.
Number 7, subset.
When one set is entirely contained within another set, it's called a subset.
Number 8, universal set.
The universal set is like a big box that contains everything we're looking at in a particular situation.
Number 9, complement of a set.
The complement of a set includes everything outside that set, the things that are not part of it.
Number 10, disjoint set.
Disjoint sets are groups that have nothing in common. They're like separate teams with different players and no members in both teams.
Number 11, union of two sets.
The union of two sets is like putting both sets together into one big set, including all the elements from both sets without repeating any.
Number 12, number of elements in a set.
The number of elements in a set is simply how many elements or members are in that set.